Hello, today we're going to be looking at the fuzzy logic code for the problem described in the report. As a recap, we want our robot to distance itself from a target by a certain amount. On the screen now is the fuzzy inference designer, and this is a high-level view on the fuzzy system I've created. On the left, we can see our position error. So in one of our inputs, position error. Our other input is robot velocity. This is run through the fuzzy system and output motor voltage to control if the robot goes forward or backwards. Taking a closer look at our inputs, starting off with the position error, we can see the membership plots. The blue line describes the membership that the robot is too far away from the target. The red describes if the robot is just close enough, and the yellow describes if the robot is too close. Moving on to our next input, we have robot velocity. Similarly, the blue line describes that the robot is moving farther away from the target. The red line describes the robot is staying still, and the yellow describes that the robot is moving toward the target. Now we can take a look at our outputs. For the output is motor voltage. The blue describes negative motor voltage, which would relate to the robot then, after seeing the inputs, deciding to move farther away from the target. The red is that the robot decides to do nothing and stay still. The yellow describes that the robot would move closer. Now, these rules need to be set in place in order for the system to know how to deal with the inputs and track them to the outputs. That's where we move to the rule editor. Rule 1 says if position error is negative and robot velocity is negative, then the motor voltage is positive. That is saying, if the robot is too far away and is moving farther away, the robot should move forward. The next rule says if the robot is too far away and is standing still, it should move closer. Then rule 3 says if the robot is too far away and it's moving closer, then it should keep moving closer. Rule 4 says if the robot is just far away enough, but is moving farther away, then the robot should instead move closer. Rule 5 is the ideal condition. If the robot is just far away and is not moving, then it should stay there. Rule 6 says if the robot is where it should be, but is moving closer, then it should back up. Rule 7 says if the robot is too close and is moving farther away, then it should continue moving farther away. Rule 8 says if the robot is too close and it is doing nothing, it should move farther away. Rule 9 says if the robot is too close and is moving closer, then it should back up. Looking at all these rules together, we can see the control surface. So the control surface describes what the robot should do at any given moment. For example, here at the top left, we can see the case where the robot is too far away and is moving farther away. The output of the fuzzy system is at its maximum and says that the robot should move forward at full speed. And as each corner moves closer towards the ideal center position, The robot takes less drastic action, sends less voltage to the wheels, and more smoothly approaches the ideal case where the robot is just far enough and is not moving. This has been simulated in Simulink here with these sliders controlling the supposed position error and velocity of the robot. These are fed into the fuzzy system described before, and we can see the outputs in this display as well as in a scope here. Running the program, we can mess with the sliders and get to a case where the robot is where it should be. Changing the position error to close to 0 and the velocity of the robot close to 0, we should be able to see that the robot is doing close to nothing. This is more clearly seen on the display than the scope, as the scope has issues with scaling itself. So as the conditions get closer and closer to both being 0, we can see that the output of the fuzzy system also gets closer to 0. Now we can explore some different cases, such as the robot is too far away and is doing nothing. The fuzzy system says that the robot should move closer. In any case where the robot is too far away, no matter the velocity of the robot, the fuzzy system will always decide that the robot should move closer. What changes is by how fast. As you can see, the output of the fuzzy system changes from around 4 to around 0.75 as we change the velocity. Now, for instance, the robot is too close. Again, we see that this fuzzy controller outputs a negative voltage, which relates to a backward movement. And by modulating the initial velocity, we can see that how fast the robot moves backward also changes. That has been an overview of the created fuzzy system for a robot tracking its distance to a target. Thank you.